All right, let's take another look at constructor functions for a little bit more info here. So we incorporated this full name method into each object, each person object that we're creating, using a function contained in this full name property. This dot full name equals our function. We then converted that function into an immediately invoking function expression, an IFI, by wrapping that function in parentheses and feeding in the two arguments we want it to return, we want it to use. Okay, that's perfectly valid, and IFIs are going to be something that we talk about more later on, and I think that this is a good demonstration of the role that IFIs can play or how IFIs can work, but nevertheless, it's not that common to actually see an IFI in a method like this. There's nothing wrong with it, but it's not that common. You are more likely to simply see an anonymous function which somehow uses properties of the parent object, the containing object. Just like this. Okay, so we're going to revisit IFIs a little bit later on. However, I want to stick to methods for a while. So again, this is an example of a method, a full name method. Let's go ahead and change this back to get full name now that it is a function which we are going to have to invoke. Okay, what I mean by that is, in order to get the full name of one of these people, one of these four people objects, person objects I created, I can't write Lisa.getFullName. This is going to return the function. I want to actually execute that function, so I need to follow it with those parentheses. And then it will return the full name as I'd like, as I expect. Now this is great, and this is all well and good, but it's time to talk about something called the prototype. The prototype. Now, in the past, you've seen me type something like this into the console. Document dot underscore underscore proto underscore underscore. And that returns an HTML document object. Okay, this underscore underscore proto underscore underscore command, it is deliberately coded so that it's difficult to type, so that you never accidentally type it. Okay, this allows you to access the prototype of any object. And I'm going to say right now, never, ever, ever edit or in any way change the prototype of an existing object or existing types of objects. Okay, do not edit prototype. So the only reason you would ever type in underscore underscore proto underscore underscore is to see the prototypes, to see what these prototypes contain, what properties and methods they contain. Okay, so this allows you to access the prototype of an object. But what is a prototype? A prototype is, I like to think of it as the genus of objects, the type of object. Evan is a male, Lisa is a female, but both of them have a prototype of person in this case, or Homo sapien if we're talking about actual people. Okay, so the prototype is really this very fundamental template that represents the object we actually see and interact with. And that prototype might have properties and methods which we do not see on an actual object. Okay, it might possess properties or methods which we don't actually see on the object. For example, if we have an array this is all we see. And if I want to view that array as an object, this is all we see. I can open up the prototype and take a closer look at that. Look at all of the functions, all of the methods that this array object actually possesses. But all of these methods exist only in the prototype. They don't exist in the object itself. They exist in the prototype. Okay, so whenever I want to run array.shift.pop.reverse, what I'm doing is I'm accessing a function or a method which exists on the array prototype, and I'm executing it. There's pop, there's push. Slice is one we're going to learn. Shift, reverse, splice, unshift, toString. These are all methods which are completely usable on an array. I can use them whenever I want on an array, but they are not coded into that specific array. They are not coded into that specific array. Now, when we use constructor functions, we can actually set methods available to the person prototype. Okay, whenever we use the new keyword, a new object is created with whatever properties are inserted via this constructor function, but at the same time, the person object, which results from Kingsley, also contains an empty prototype object. An empty prototype object. Okay? But in the same way that we add properties and methods to our actual person, we can also add properties and methods to the prototype of a person. Okay, this is confusing stuff, so let me just walk you through a demo real quick. I'm going to do it down here. Person.prototype dot get full name equals, and I'm going to copy this function down here, and I'm going to eliminate this method entirely from our constructor function. Okay, so now I'm adding the getFullName method to the prototype of our person objects. So let's see if it still works. Reload my page, look at Evan, first name, last name. There's no getFullName anymore. There's no full name anymore. But can I run evan.getFullName? It still works. Oop. GetFullName still works. The reason is I type .getFullName and invoke it, and the browser starts looking for this property on my Evan object. And it doesn't find it. It doesn't find it. So then it goes backwards and looks at the prototype and sees if it can find it there. If it can't find it there, it's going to throw an error, or you're going to return undefined. But it doesn't find getFullName on the actual person object itself. It does find it on the prototype, so it is capable of executing it. And note that in the function, inside the method, living in the prototype, we're still using the keyword this, or the variable this, to specify the object that we're actually referring to. So this, when I run it when I run Evan.getFullName, this is the Evan object. If I were to run Brian.getFullName, this would refer to the Brian object. And yet, this method exists on a shared prototype, a prototype that is shared between all four of these people. Okay? So it's almost like we're creating an entirely new class of data type in JavaScript. We've created a person data type, which has a unique method called getFullName, which you can execute on any person data type imaginable, on any person object, even though we don't see it here. Even though we don't see it, if we inspect Brian, we know that, oh, it's a person. So we can run getFullName on it. Just like when we see an array, we know, oh, it's an array, so we can run .shift. Or we can add square brackets and access a specific item at a specific index. Okay, now why should you care? The prototype it can be extremely useful when you're using constructor functions. You're probably not going to have to use it too much anytime soon. But let's think of it this way. We have 4 people here, and each of these 4 people, these 4 persons, I'll call them persons. I'll be strict about it. Each of these 4 persons has 2 properties. Before, when we had getFullName as a method inside our constructor function, each of these objects had 3 properties. So we've gone from a total of 12 properties in 4 objects to 8 properties in 4 objects. Every one of those properties takes up space in memory. It requires additional computing time. It can slow down your code. We only have 4 people, so it's a pretty insignificant difference ultimately, but it's also a 33% reduction in the amount of code that our browser has to read. 1/3 of, well, that's not true at all. It's not 33%. But we got rid of a good chunk of code. 33% of the properties which the browser has to read have been eliminated. So we only have 4 people, but what if we had 400? What if there was 1 person object for every student in Codify? There would be hundreds of person objects. And each one of those objects would need to have the .getFullName method, unless we chose to add it to the prototype. Then it only occupies 1 little spot in memory. And it can still be accessed at any time in reference to any specific person simply by reaching into the prototype. Okay, and this is a principle called Prototypal Inheritance. Again, probably not something you're going to need to think about too much yet. But eventually you will, and you should. Okay, prototypal inheritance is an important concept. All it means is when you have an object, if you try to execute a method or call a property on that object and the browser doesn't find it, then it's going to start looking at the prototype. And if it doesn't find it there, it's going to look at the prototype of the prototype. Surprise, surprise. And if it doesn't find it there, it's going to look at the prototype of that prototype, etc., 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 until it either finds the property you're looking for or it does not. Okay, so just to show you what a prototype of a prototype might be, I'm going to create another array, type underscore, well, no, I'm just going to call it. We'll open it up, and down here we see the prototype is an array. Okay, it has an array prototype. Now let's open up that array prototype And all the way down at the bottom, we see a prototype for the prototype, and it's an object. No prototype to the object prototype. The object is as far deep as anything can go. That's why JavaScript is referred to as object-oriented programming. Everything is, when you get right down to it, an object. So if I type 1234 dot underscore underscore proto underscore underscore, this shows me, see there's pop, this shows me the array prototype. If I type 1234 proto dot underscore underscore proto again, then I get the object prototype. Okay, so that's a lot of high-level information. Point is, when we use constructor functions to create a new object on the fly, a new type of object, we're also creating an empty prototype element, prototype object for that new type of object. And we can add custom methods or properties to that prototype in order to be efficient in our code and frame this new type of object for a specific kind of use. So let's try this one more time. I'm going to add a new function, a new method to the prototype. I'm going to add person.prototype.get formal name, and this is going to be a function which simply returns this dot last name plus comma space plus this dot first name. So, what do you think that's going to look like? Get formal name. Oh, do I not have a mat person? I don't have a mat person. Let's do Kingsley. There you go, Papa Giorgio, comma Kingsley. So with a prototypal method, we have formatted their full name into a more formal format. All right, so hopefully this has been interesting. We're going to practice a little bit using prototypes in the exercises, but not a whole lot. It will be something that comes up more organically as you get into deeper and deeper JavaScript. In the meantime, let's practice creating some new types of objects with a brand new constructor function. So I'm going to call this one function restaurant. Okay, and this object is going to have a name, and it's going to have a seats, and it's going to have a cuisine, what type of food it is, and it's going to have an average price, so average price per entree or something. And finally, let's do a rating. Okay, so that means I need 1, 2, 3, 4, 5 parameters for this function. I need a name parameter, I need a seats parameter, I need a cuisine parameter. I'm just seeing that I spelled that wrong. I need an average price parameter, and I need a rating parameter. And there we have our constructor function. Now let's create some restaurants. Let's do var OSHA. Oh, not a capital O. Var OSHA. This is going to be a new restaurant. Its name is OSHA. Note that I wrote it in as a string. Seats, let's say 100. Cuisine, also a string. It's Thai. Average price, let's go $18. Actually, let's do that as a string as well. $18. And then rating, 4.5 out of 5. And then let's do var Subway. Subway sandwich. It's just going to be Subway. Seats are going to be 10. Cuisine is going to be sandwiches. And rating is going to be 1.3. And one more. How about loud table? New restaurant. Loud table. Seats 90. Cuisine Laotian. Average price. I didn't do an average price for Subway. $8. Average price at Loud Table, maybe 26. And a rating of 4.7. Okay, so we've created 3 new restaurants. I just picked 3 places near the school. So we've created the restaurant objects, but now where are they? They're all stored in a variable each, which is fine, but a little inefficient. If we wanted to do something with these restaurants, we would probably want to gather them all in one place. We'd probably want them all in an array of some kind together, some place where we can access them in one spot. So what can we do to ensure that anytime we create a new restaurant object, we also push that object to a specific array? Well, we can create a new array called restaurants, empty array, and inside our constructor function, we can actually push the new object we're creating to this array. And in so doing, we don't have to create 3 new variables. We could just execute new restaurant with the given parameters whenever we want. It saves us a little bit of code, but more importantly, it saves our browser from having to remember 3 additional variables. And imagine if you were canvassing all the restaurants in the financial district of San Francisco. You'd have dozens, if not hundreds, of restaurants. You don't want dozens, if not hundreds, of variables, especially in your global execution context. So instead, we're not storing each new restaurant in a variable. We're pushing each new restaurant into an array, which is stored in one variable. So this is just a really simple way to make your code more efficient and to point out that a constructor function does not have to be totally confined to creating a new object. You can execute other code inside your constructor function that helps you set up your data. Okay. Now, to make this a truly functional function here, I would want to refactor this act of pushing the new object excuse me, the new object to the restaurants array. partially because we have to reach outside of this function to get to that restaurants array, right? But also because I want my functions to be as simple and contained and single-minded as possible. So we have one task being completed, and here's a completely different task. So I'm going to go ahead and cut this out first. I'm going to create a new function. We'll call it push to array, and it's going to take an array as an argument, and all it's going to do is array dot push. Actually, it needs to take two things as an argument: array and item. Array dot push item. And now how would we set up our constructor function to execute this function in the way that we want? Well, inside our constructor function, we're going to invoke push to array. The array is going to be restaurants, and the item is going to be this. Problem is, we're still reaching outside of our function to get this restaurants array. So what we probably want to do is add it as a final parameter in our constructor function. So now, as we create these new restaurant objects, we're also going to tell it which array to push to. So maybe we have multiple types of constructor functions for multiple types of objects, and we have 3 arrays: restaurants and bars and lounges, I don't know. And we want to be sure that this new restaurant item is pushed to restaurants. I'm going to reload. I'm going to call the restaurants array, and we have 3 restaurant objects in here: OSHA, Subway, and Loud Table. Now I will say this is very functional code, which is great. However, the fact that this is a restaurant object means it's probably okay if you need to reach outside of this function to the restaurants array. That is not a big deal in this case. I just wanted to show you the extreme. The reason why this is not a big deal is because let's say we do have another constructor function for bars, and we have another array for bars. Well, the reality is all we would need to change is this. It's still pretty efficient code. It's not 100% pure, but it works. And it does what it needs to do, and it's still very contained and specific. Restaurant, restaurant, bars, bars. Actually, bar would be this constructor function name. Okay, so something like that is completely okay. I don't want you to go crazy trying to make your code as pure as possible at this point in time. But anytime you spot places where your code can be refactored, refactor it. When I say refactored, I mean if I didn't write this push to array function, we would have to write this twice in each function. Refactoring it like this simply confines the act of pushing to a completely separate function. It means that if ever there's a problem with the code that's happening in here, we're going to have a very small scope, very small block in which we're going to need to look to track down that problem. Okay, so hopefully that was helpful. 2 different constructor functions for 2 types of objects, and 1 separate function to push them into a specific array.